Question 3 is coming from circular measure. The diagram shows a sector of a circle with center C, the radii CA and CB each have the length R, and the size of the reflex angle ACB is theta radians. The sector shaded in the diagram has a perimeter of 65 and an area of 225 centimeters squared. Part A, find the values of R and theta. So I'll begin from what I'm given. Area of the sector, you know it is a half R squared. Okay, area of sector is equal to a half R squared theta, and this one is now equal to 225. Then I can make theta the subject of the formula here. I can cross multiply 225 times 2, that one will give us 450. Okay, then I can divide all through by R squared. So this will be 450, then divide by R squared. And then after that, we can also go to the perimeter. Perimeter is equal to, let's look at the lengths which are surrounding the shape, right? We have this radius, and then the arc length here. So we shall have R, then plus R, and then plus R theta. And then we equate this one to 65. Okay, R plus R, that one will give us 2R, then plus R here. Our theta is 450 over R squared, which is equal to 65. And then from here, we can simplify this one to 2R, then plus this R here will reduce this one here, and then you have 450 over R, which is equal to 65. Now I can multiply everywhere by R, not so? So if I multiply everywhere by R, that means I will have 2R squared, then plus 450, which is equal to 65 of R. So rearranging this to get a quadratic equation will be 2R squared minus 65R, then plus 450, which is equal to 0. And then after reaching here, I can use my calculator to see whether it is factorizable. I will go to equation, that is 5, then quadratic is 3, that is a 2, then negative 65, then 450. This one is 45 over 2, and then 10. So I can skip space here, and I say R is equal to 45 over 2, and then also R is equal to 10. Remember, you are not supposed to do this in the exam, that when you reach here, then you just write these answers. You need to show the examiner that you have solved the equation. So how do you do that? You can skip the space like I've done here. Then you can cross multiply. You need to give us the factor from which these roots are coming. Okay. So when I cross multiply here, I will get 2R, then bring the 45, it becomes a minus, right? So I will have 2R, then minus 45. And then here, bring this one here, it will become a minus. So we shall have R minus 10 is equal to 0. By doing this, you have already cheated the examiner. You see that? Because they need this part here, an attempt to solve the quadratic equation. Now, we need to find the value of theta. And when you check here, theta is equal to this one here. So I can say 450 over this one here, 45 over 2 squared. What do you get? And then we also have theta, which is going to be equal to 450. Then we divide by 10 squared. Of course, this one will be 100. So 450 over 100. This one will give us 4.5, right? 4.50. And how about this one here? 450 divided by, we have 45 out of 2, then squared. This one gives us 8 over 9. 8 over 9, which is 0.8 recurring, okay? But then when we look at our theta here, this theta, it is a reflex angle, okay? So if it is a reflex angle, that means it has to be bigger than 180. because if I draw like this, maybe this one to be 180, then there is something that is added on. So it is bigger than 180, and 180 is pi. Okay, so pi is 3.14 and the rest of those figures. So this one here, the 4.50 is greater than pi. This is 0.888 recurring, okay, which is less than what? Pi. So because this one is less than pi and this one is greater than pi, this is the one for the reflex. So I'm going to take my theta to be the 4.5, and then the r that gives us the 4.5 is 10. So I'll take this one as my radius. Okay, so this simply implies that I'll say since theta is reflex, okay, then r is equal to 10 centimeters and theta is equal to 4.5 centimeters. That is that. Part B, find the area of the triangle ACB. Area of the triangle ACB. So this one here. So we need to get to this area. Since we have the radius on this one, then we just say area of that triangle is a half times the radius, then sine of the angle in between here. But this one has to be 360 minus the theta, right? Because angles at a point sum up to 360 degrees, and already we know this one. So I just subtract it from 360. So area of that triangle, area of triangle ACB is going to be equal to a half times r times r, then sine of 2 pi minus theta. Now, what is r? R is 10. Okay, 10 squared, and then sine of 2 pi minus theta is 4.5. Yes, 4.5. The calculator here has to be in radians. So what we get altogether to 3 significant figures. My calculator here is in degrees, so I'm going to turn it to radians, shift then mod, rad is 4. Then 100 divided by 2, that one will give us 50, then sine. Then we shall have 2 pi, then minus the 4.5. And we get 48.9 to 3 significant figures. 48.9 centimeters squared, 3 significant figures. As simple as that.